All right, today we're going to go ahead and finish 3.1 and then start the first part of 3.2, okay? All right, we're going to continue the discussion on how mean, median, and mode are affected by skewed data sets and kind of their placement in the distribution. And then we're going to also get into what a weighted average is, okay? All right, so let's skip ahead a few pages. All right, so for the following distributions, this is where we left off. Label the approximate location of the mean, median, and mode. Okay. In general, when it is mound-shaped and symmetric, the values of the mean, median, mode are going to be about the same. All right, so once you label that on this first distribution, the mean, median, and mode are all kind of right there in the middle, approximately the same. Okay, but once we get to skewed distributions, some are affected more than others. So, for example, let's just say we had a skewed left distribution and my data set kind of looked like this. Let's just say we maybe had some, I don't know, maybe some test scores, right? We got 80, 85. You don't have to write this down, just watch. 90. So right now, the mean, median, and mode are all the same. This is a symmetric distribution, even though it's small. But then if I add a very low score, like maybe 10, well, how did that affect the median? Well, the median now is just going to be 82.5, right in between these two. However, the average is affected a lot. Okay, that's affected more. It's going to be pulled more towards the lower values or the tail of this skewness. So here's what you need to know about this distribution. If it's skewed left, we'd expect the mean to be pulled further left than the median. Okay, the median just kind of moves over a place, right? Because it's the middle value. So just moving that over a place doesn't affect it as much as the average would. Okay, and then the mode, of course, is still the most occurring. You know, this is a histogram, so this obviously is the most occurring because it's frequency or relative frequency there. Okay, so just the opposite happens if it was a skewed right distribution. We've got the mode, the median isn't as affected as much, and then the mean would be the most affected. Okay, which we kind of talked about this yesterday too. That's why if you have a skewed data set or outliers, we tend to use the median more than the mean. Okay, if you don't have a skewed data set, we like averages. It's easy to understand, so that might be our choice. But all three are good choices. Okay, so let's go on to weighted averages now. Okay, let me go ahead and pause the video and allow you to read this paragraph and then write in this description of this formula, and then I'll walk you through an example. Okay, go ahead and pause now and read. Okay, so this reads sum of the x value times the weight. There really should probably be parentheses right here for the formula because we want to find the x value times the weight for each individual outcome and then add it up and find the sum. Okay. So let's take a look at this example 4. Midterm score was 83, final exam 95, and they're going to weight your final grade using 40% and then 60% for the final. Okay, this is exactly not same weights, but this is how your grade is computed in Synergy. Okay, so here we go. Let me take you right through this. I want you to write down weighted average equals, this is just the formula up above, the sum of x times the weight. So let's focus on the numerator right now. Okay, so the x value was the 83 that you scored on the midterm, but that's weighted at 40%. So that's the product there that they're talking about. Okay, plus what's our other score? 95. What was the weight? 60%. Okay. All right, and then the weights are just the 0.4 plus the 0.6, so that's going to equal 1. All right, so then we go to our calculator, we plug this in, we end up with 90.2 up top for the sum, and just being divided by 1. Okay, pause if I'm going too fast. All right, so the answer to the question, will you earn an A? Yep, it's above 90, so they did earn an A. Okay. All right, there's a little different style of this. On page 103, number 24, I want you to go there and take a look at that, and then I'll walk you through how this is a little bit differently, okay? Okay, so you see how this one's presented. Now it has like points instead of percentages. So where they had no context to this, let me give you an example where this might occur. Let's just say you're taking some college classes and you got a 2 credit hour class and a 3 credit hour class. Well, the 3 credit hour class counts for more on your GPA than the 2 credit hour. You spent more time and more difficult, or however you want to justify that. So that's where they would take the 4, because if you got let's just say you got an A for your 3 credit hour class, you'd go 4 times 3 plus, and then this one was a 3 point. If you got a B, and it was only a 2 credit hour class. So you multiply those and then divide by the sum of the weights. Okay, and the sum of the weights would be 5. So that's how you'd figure out your GPA for something like that. All right. So here's how we will address a problem like 24. Okay, they said the weight was 5 and the amount given or the credit given was 10. I can't remember the correct word on that. I'll check here in just a moment. Go ahead and keep writing that down. Okay, I just said 10. So like 10 has a weight of 5. 20 has a weight of 3, and so on. Okay, and then the sum of the weight, I just do the 5 plus the 3 plus the 2. Okay, so there's 17. So initially, if they had equal weights, 10, 20, and 30, we would expect the average to be right in between, 20. But since this number was weighted more than the others, it makes sense that it's below 20 and at 17. Okay? All right, I think that wraps up 3.1. It does. So let's transition to the first part of 3.2. Go ahead and turn the page. All right, so 3.1 was measures of center, central tendency. Now this is measures of variation. Variation is just kind of another word for spread. Okay, what's the spread of the data look like? Okay, we're just going to start with range today. We actually already used range a little bit. Standard deviation takes a little more time. I think to do that justice, I'm going to wait till tomorrow on standard deviation and variance. All right, so the range. We use this for finding class width already in chapter 2. It's going to be the difference between the largest and the smallest values of a data distribution, or we sometimes say max minus the min. And that's a measure of spread. Okay? How spread out is the data? Was the temperature today range from a low of 10 degrees to a high of 20? So that would have a range of 10 degrees, or did it go from 5 degrees all the way up to 35 degrees? That would be a range of 30, right? That's a measure of spread. Okay? Okay, so I want you to pause for a moment, read through example 5, okay? And then they want you to answer some questions about the range and the mean, and then we'll discuss part C, okay? So go ahead and pause, give yourself a couple minutes to do that. All right, so for the first supplier, the range was 10 ounces, and so was supplier 2, 27 minus 17 for both of them, 10 ounces. The mean was also 22 ounces for both, if we add them up and divide by 5. Okay? So even though this measure of spread was the same, the spread is actually a little different if you look at these. That's what kind of part C is asking us to do. Let's really analyze the weights of these blueberries. For supplier 1, these data values were a lot closer to the mean or average of 22 ounces. Whereas supplier 2, they're a little more volatile, I guess. You know, they have the distance from the mean of 22 is higher than these. All right. So that's kind of where we're going to go with what's called a standard deviation. So it looks like they have the same spread, but if we were to break it down to another measure of spread called standard deviation, we'd see a difference. Okay. So that's why they said supplier 1 provides a little more consistency, and that might be something that they would prefer. Okay, so we will just stop there for today and continue on with the others tomorrow.